For most of human history, we assumed the deepest parts of the ocean were dead. Not inhospitable, dead. The logic seemed airtight. No sunlight, temperatures near freezing, pressure so extreme that a human body would be crushed instantly, and no obvious source of food to sustain anything more complex than a single-celled microbe. Scientists actually used to call this the Hadal zone, anything deeper than 6,000 meters, a biological desert. And it made perfect sense. You'd really only expect to find total darkness, pale sediment, and utter silence, because whatever sparse nourishment manages to drift all the way down from the surface waters far above, things like marine snow or the occasional whale fall, it thins out so rapidly with depth. By the time you sink past the abyssal plain and finally descend into those deep Hadal trenches, the conventional food supply is pretty much down to zero. That long-held assumption that the deep was simply sterile was powerfully reinforced by our very first glimpses into the abyss. Think back to 2012, when filmmaker and explorer James Cameron made that historic solo descent right down to Challenger Deep in the Mariana Trench. The exact words he used to describe the view from his tiny porthole were desolate and alien. When he took his specially built submersible to the absolute bottom of the world, all he saw out there in the gloom was a flat, empty plain with almost nothing moving. For decades, that stark, haunting image just held still in our collective imagination. The deepest ocean was simply a void, the endpoint to the reach of life. But as we've recently discovered, that void was quietly erased. In the summer of 2024, a Chinese submersible named Fendouzhe, which translates simply and beautifully as Striver, made 23 daring dives right down into the crushing depths of the Western Pacific. Dropping miles and miles through black water, the Striver slipped right past the boundaries of our understanding and rewrote the rules of where and how life can exist on this planet. It was an expedition that would systematically prove we had been measuring the limits of biology against the completely wrong ruler. Led by researcher Xiaotong Peng of the Chinese Academy of Sciences, the team spent their time exploring the Kuril-Kamchatka and Western Aleutian trenches. When their findings were finally published in the journal Nature on July 30th, 2025, they detailed an environment that absolutely no one expected to find. You have to remember, they were looking at tectonic plate boundaries, places of immense, slow-motion geological violence, where the Pacific plate is inexorably sliding beneath its neighbors. And instead of that barren, featureless wasteland that Hadal science had prepared everyone for, they found a hidden, flourishing world. What the Fendouzhe actually illuminated in that pitch-black water wasn't a desert at all. It was a city. An actual city of frenulate tube worms, growing in clusters so incredibly thick that they practically carpeted the rocky seafloor, extending vibrant, blood-red, hemoglobin-filled tentacles straight out into the freezing cold water. These organisms weren't just barely surviving down there at the edge of extinction. They were thriving in a highly organized, teeming ecosystem. We're talking about a community operating on entirely different biological rules than anything science had previously documented at these crushing depths. A vibrant oasis, surviving under thousands of meters of water. And that breathtaking scene of impossible life melts seamlessly right into dense beds of bivalves, clams, and mussels, some of them reaching up to 23 centimeters long. These creatures have spent millions of years evolving in conditions that look absolutely nothing like the shallow, sunlit seafloors their distant relatives occupy. They were packed so tightly into the pale sediment that they formed massive, ancient clam beds, completely obscuring the dark rock underneath them. And living right alongside them were pale sea cucumbers, delicate, feathery-armed sea lilies, and spiky crustaceans, drifting like ghosts through the freezing water column. It's a complete, intricate food web, functioning in total darkness. Drifting over this entire alien landscape, the scientists also discovered an ethereal undersea dusting. Imagine white, snow-like microbial mats spreading across the jagged rocks, glowing pale against the deep-sea basalt. They were so striking, so beautifully strange in that absolute dark, that the scientists, hovering just outside their submersible windows, couldn't help but give them poetic names. They actually called these brilliant white patches Cotton Field and Winter Sweet Valley, because unlike a barren, dead desert, These living landscapes felt like places that deserved names. Then there's the staggering depth of this discovery: 9,533 meters. That is the deepest living animal colony ever recorded on our planet. Let that sink in for a moment. At nearly 10 kilometers below sea level, the pressure down there is a crushing 8 tons per square inch, more than 1,000 times the atmospheric pressure you and I feel at sea level. Keep in mind, fewer human beings have ever visited this extreme environment than have literally walked on the surface of the moon. To find a sprawling, complex ecosystem at this mind-bending depth isn't just a fascinating little scientific footnote. It's a complete rewrite of biological limits. So how is this even possible without a single photon of sunlight? To understand that, we have to look at an entirely different biological engine: chemosynthesis. Pretty much everything alive on Earth, from a blade of grass to a towering redwood tree, right up to a blue whale, depends ultimately on the sun. But chemosynthesis is a completely parallel biological system. It's the conversion of carbon molecules into organic matter using the oxidation of inorganic molecules, an incredibly ancient system that runs entirely, and almost miraculously, on raw planetary chemistry. At the very bottom of these Hadal trenches, the relentless grinding of the Earth's tectonic plates creates enormous geological faults. You can think of these fractures as natural planetary plumbing. They seep methane and hydrogen sulfide from deep within the Earth's crust directly out into the ocean. On the surface, those caustic chemicals would be highly toxic, even lethal to most life. But down here in the deep ocean, specialized microbes have evolved over hundreds of millions of years to essentially harvest them, taking those chemical bonds and using them as a pure energy source, building the foundation for a rich food web right from the bottom up. And the animals living in the trench have evolved an incredibly intimate relationship with those resilient microbes. The tube worms we talked about earlier actually harbor these symbiotic bacteria directly inside their own bodies. This biological partnership is so complete that, over evolutionary time, the worms actually lost their own digestive systems entirely. They no longer possess mouths. They don't have stomachs. They just live completely off the chemical energy their internal bacteria continuously produce, sitting there, rooted firmly in the sediment, drawing their life from the steady breath of the Earth itself. And perhaps the most breathtaking aspect of this entire discovery is its scale. These chemosynthetic communities stretch continuously for 2,500 kilometers across the trench floor. That means this isn't just an isolated curiosity, or a single lucky group of animals situated on a random thermal vent. It is a vast, continuous ecosystem, comparable in length to the entire Amazon River, and it's been hiding perfectly out of sight in the absolute dark of the ocean floor, instantly expanding our understanding of the Earth's biosphere by millions of square miles. This vast, hidden architecture weaves directly into our understanding of the global climate, too. You see, this dark ecosystem acts as an active deep-sea carbon sink. The microbes down there are actively oxidizing greenhouse gases like methane right as they seep from the crust, converting a highly potent gas into much less harmful compounds before it can ever make its way to the ocean's surface. Meanwhile, all those bivalves and tube worms are continuously burying carbon in stable organic forms deep within the sediment. So these Hadal trenches, which we have literally spent generations treating as irrelevant geological voids, are actually actively working to balance our planet's chemistry. And that realization flows right into a very urgent, modern reality. For years, the push for deep seabed mining relied heavily on a specific, very comforting assumption: that the Hadal zone was a dead, empty desert, where the industrial extraction of rare minerals would cause little to no biological harm. But the reality we are seeing now dismantles that idea entirely. We are looking at an ancient, extraordinarily fragile, and extremely slow-growing ecosystem. Disrupting the deep sea floor means destroying a complex biological network we've only just learned exists, a network that operates on profound geological timescales. When we expand our perspective outward, the implications become even more profound. What this discovery essentially proves is that the ultimate boundary condition for complex life is chemistry, not sunlight. We've spent generations assuming that where light couldn't reach, life simply couldn't organize into anything more complex than some isolated bacteria. But wherever the geological forces of a planet create the right chemical energy exchange, it turns out life finds a way to be there. Not just tentatively, not barely hanging on, but abundantly, forming thriving cities in the pitch dark. And that deeply connects the crushing depths of our own ocean to the wider solar system. Because if complex, chemosynthetic life can thrive at 9,500 meters down, it radically transforms our search for life on other worlds. We look up at the icy, subsurface oceans of Jupiter's moon Europa or Saturn's moon Enceladus, where plumes of liquid water and organic chemistry vent violently out into the vacuum of space. The conditions we suspect exist beneath that thick ice strongly resemble the dark, pressurized, chemically rich environment of Earth's own Hadal trenches. We are left with a profound new truth about the resilience and the architecture of life. It does not simply survive at the bottom of the world. It has built something there, quietly, over millions of years, in the absolute dark, waiting for someone to come and look.